This mini lesson is on slope of a line, and just going back over some of the formulas here, we're going to be using, we're going to be looking at the slope formula given 2 points, and we're going to be looking at slope-intercept form, which is y equals mx plus b, where m is the slope of a line and b is the y-intercept. Standard form we'll look at. If we have to find the slope, we might have to convert from standard into slope-intercept form. And this lesson, we will not use this, the point-slope form. So look, let's talk about slope. What is slope? Well, slope is the slant, steepness, or the incline of a line. In mathematical terms or definition, it is the what we call rise over run. And when you think about rising is up or down, run is left or right. And of course, rise over run, we can still use that y2 minus y1 over x2 minus x1. Because if you think about rising up and down are the y values. So it's the change in the y, which is this top portion right here, over the change in x. Well, that's our horizontal change, which is this direction, which is our run, left to right. So of course, using this graph, you can see there's 2 points on the line, and we can determine the steepness of that line by going up and right. And we can go up 4 and to the right 3, which gives us our slope, which is 4 over 3. We can find slope 3 ways. We can find slope if we have 2 points. We can use the slope formula. If we have a graph, we can use rise over run, going up or down and then left or right. And then if we have the equation, if it's in slope-intercept form, then we can find the slope by looking at the coefficient of x. So the first example is to find the slope of the line through the following points. So let's label, this is x1, y1, x2, y2. Keep in mind the x1, y1, x2, y2, those subscripts, all that tells me is that this is point 1 and that this is point 2. So we're going to substitute this in to our slope formula. I'm going to write it out. All right, so our formula automatically has a minus, so we're going to plug in our numbers. We have y2, which is -1, minus y1, which is 3, over x2 is 4, minus x1, which is a -2. Now be careful. Notice that our formula is always a minus. We are subbing in a negative coordinate. So we're going to have a change of sign here. So instead of being minus, it's going to become positive. So we'll make that change down here. All right, let's simplify the numerator and the denominator. We have a -4 over 6, and we want to reduce, so that would reduce to -2 over 3 for our slope of a line. Let me change the color here. Okay, it's -2 over 3. I'm going to change it now. I didn't realize the blue was not showing up as well. All right, next example. Let's label these again. x1, y1, x2, y2. Now I'm not going to write the formula again, so let's just go ahead and sub in using, this here. All right, y2 is 3, minus y1 is 3, x2 is a negative 6, and then x1 is a positive 5. Simplify the numerator. 3 minus 3 is 0, over negative 6 minus 5 is a negative 11. 0 divided by any number is always 0. So the slope of this line is 0. Using the same formula again, we're going to label the point x1, y1, x2, y2. All right, y2 is 0, y1 is 1, x2 is negative 4, x1 is negative 4. Simplify the numerator, simplify the denominator. That's going to change to a plus. Well, what happens? That becomes 0 in the denominator, and 0 in the denominator is undefined. There's no number times 0 that will give you whatever is in the numerator. All right, finding slope from a graph. So to find slope from a graph, we are going to use these 2 points that are bubbled in for us, and we're going to think about rise over run. Let's just start on the point on the left. So I'm going to start at this point right here. Now I'm going to count down, because rise, remember, is up or down. So we're going to go down, and then we're going to go to the right. And let's count. That's 1, 2, 3, 4. Down is going to be negative, so that is a negative 4. To the right is positive. We're going 1, 2, 3. So the slope of this line, rise is down 4, run is to the right 3. So the slope of this line would be negative 4 over 3. You could also look at this line and see that this line is from left to right, that this line is going down. So that would tell us that the slope is going to be negative. Now I can look at the second one over here, this graph, and I can tell that the slope is positive because this line is going up, increasing. But let's find the actual ratios. So we've got our 2 points. We're going to start at this point on the left, and we're going to count up. 1, 2, 3, 4, 5. So that is 5 for the rise. Over, we're going to run 1, 2. Up is positive, to the right is positive, so our slope of this line is a positive 5 over 2. Find slope of a line in slope-intercept form, or with an equation. Here we have, this is y equals mx plus b. So if I want to name, let's find slope and the y-intercept. So our slope here is going to be the m, which is the coefficient in front of our variable, our x. So it's negative 2 over 3. And then our y-intercept is this number on the end, our b. So we're going to name it as an ordered pair. It would be the point 0, 5. Our b, this equation, is not in slope-intercept form. So let's put it in slope-intercept form by solving for y. So we're going to move the x by subtracting it. That gives us a negative 5y equals negative x plus 10. We're going to divide every term by negative 5. So we have y equals, a double negative makes that a positive 1 over 5x. And then when we divide, that's going to be negative 2. So our slope is going to be 1 over 5. Our y-intercept is going to be 0, negative 2. So slope of horizontal and vertical lines. Horizontal lines, their slopes are 0. To show this, let's look at using that formula, rise over run. So what I'm going to do, I'm just going to pick 2 points on this line. If we think about rise over run, if I'm going from this point to this point, notice that we don't rise, we don't go up or down. So that means that our rise is 0. But we can run 1, 2, 3, 4, 5. But what is it, 0 divided by any number? Well, it's always going to be 0. So the slope of any horizontal line is always going to be 0. And I just realized I copied the wrong graph. So let's just draw us a vertical line. So let's say this is our vertical line, and we wanted to find the slope of this line. Then what we're going to do, let's pick 2 points on the line. Our rise over run. So if I'm going to start at the bottom point and go to the top, we will rise 1, 2, 3, 4, 5, 6. To get to that top point, do we go left or right? We do not. So that means 0. What is any number divided by 0? It is always undefined. So the way I say is to keep getting them confused, think of a horizontal line being level, straight across. You could also think of it in terms of a treadmill. If you've ever been on a treadmill, the incline of the treadmill always starts out as 0. And I always say, think of a wall as a vertical line. Can we walk up the wall, or anyone walk up walls? No, it is impossible. So therefore, it is undefined. And then just a couple of things, slopes of parallel lines and perpendicular lines. So let's say the slope of a line is 5. Well, parallel slope is going to be the same, so it's 5. And then perpendicular, oops, erase that. Almost. Perpendicular lines are going to have opposites and reciprocals. So what we have to do is take the reciprocal of 5, which is 1 over 5. Since 5 is positive, the opposite of it is going to be negative 1 over 5. What if we have negative 1/2? Well, parallel slope would also be negative 1/2. Perpendicular, the reciprocal of 1/2 is 2, and the opposite would be positive. What if we have 0 slope? Well, parallel would be 0. Well, the opposite of 0 is going to be undefined. Or we can do vice versa, undefined slope. Parallel would also be undefined, so the reciprocal undefined is 0. And let's say the slope is 1. Then parallel is 1. Perpendicular, the reciprocal of 1 is just 1. So then the sign here, since it's positive, would have to be negative.